So how many equations we have? Equations, we have 2 unknowns. How many? V1x, V2x, V1x prime, V2y. Oh, sorry. V2x, V1. Sorry, V1x prime, V2x, V1y prime, V2y prime. We have 4 unknowns, right? We have 2 equations. So it's terrible. We need 2 more constraints. So need 5 step, needs 2 more equations. What is it? Because it involves impulse, right? We can invite E. Okay, that is the relative velocity before and the relative velocity after. And what is the relative velocity before impact? V1 minus V2. What is the relative velocity before impact? Normal, yes. So that is V 1x, okay, and V2x, and because V1x is this direction and V2x this direction, so resulting, if E, just to consider the magnitude, it has to be plus, because that is the relative velocity. Because that is the definition. And what about the relative velocity after impact? Then I say V2 prime x and V1 prime x. Okay? And I put minus sign over here. Okay? V1 prime x go this way and V2 prime go that way. Okay? Which one is correct? It should be plus or minus, or this one has to be minus or plus. Okay. Assuming that here we say, assuming that because it collided this way, assuming that it moved that way, okay, then I can say the relative velocity would be V2x. That way, then the relative velocity has to be additive or subtractive. Additive? Okay, I am here, I am going that way, and you are stationed. Then the velocity you measure is like 1 meter per second, and you are moving away from me. Then you feel that my velocity would be more than the velocity that you felt when you were stationary. Because velocity is a simply change of position. And in this case, change of position with respect to time is very large. Then I will ask you, what about this case? Same increase of relative velocity? Huh? Yes? You sure? Same? Same? I want you to work out that on your classroom note. Okay, you have to do it. I don't know. No, I do know, but I have to say I don't know. Okay. So now, you have this equation, but still we need one more equation.
저기 밑에 분모가 플러스라고 한 말은 V2x가 크기를 말하는 거잖아요. 그러면 저기 위에서 저 x 방향 운동량 계산할 때 m1 v1x 마이너스 m2 v2x 맨 위에
This one?
아니요 그 위에 거 맨 위에 만약에 저기서 저 식이 맞다고 하면 이미 V2x에 마이너스가 포함됐다는 말인데 그러면 밑에는
This is the coordinate I select. M1 V1x because the velocity, assumed velocity in this direction. Therefore, this has to be minus. Yeah, you are correct. But I didn't offer any prize in this class. So, yes, you are right. I'm not saying everything I'm writing here is correct. I said in the beginning of this lecture, I will make many mistakes. And what other mistake? This one? What about this one? Minus? Huh? And what about this one? Plus? Okay, that's good. What about this one? Okay, looks like. What about this one? That's okay. Right. The reason why we invited coordinate is because we attempt to write down the graphical expression in terms of scalar expression. So we have to be very careful to select plus or minus sign. And that has to follow the coordinate we selected. Okay? And what other thing we have to invite? Another coefficient of restitution in tangential direction. In tangential direction, there is no impact, right? Therefore, in tangential direction, the linear momentum has to be conserved. But we already wrote down this, right? Right? So can you solve it? Certainly yes, because we assume that we know this theta and this theta. Therefore, we do know the relation between V1x and V1y and V2x and V2y. So probably we can solve it. Okay, this kind of procedure is recommended. Okay? What about if we have many particles?